When physicists describe reality, they do not use objects, they use equations. This alone should be unsettling. We experience the world as solid, textured, resistant. We see color, shape, motion. We touch surfaces. We feel weight. Reality appears material. Physics does not begin with material. It begins with structure. At the most fundamental level, what we call particles are not tiny pieces of matter. They are excitations of mathematical fields. These fields are not visible. They are not tangible. They are defined through equations that describe how values change across space and time. Matter, as we know it, emerges from mathematical relationships. This is not metaphor. It is how modern physics operates. The standard model of particle physics does not describe little balls moving in empty space. It describes interacting quantum fields governed by symmetry principles and conservation laws expressed mathematically. The equations come first. The particles come from the equations. This reverses intuition. We assume mathematics is a language invented to describe reality. Physics increasingly suggests the opposite, that reality behaves mathematically, whether we describe it or not. Symmetry is a clear example. The conservation of energy exists because the laws of physics do not change over time. This is not coincidence. It is a direct mathematical consequence of time symmetry. If the structure of equations remains invariant under time translation, energy must be conserved. Energy conservation is not imposed. It emerges from mathematical consistency. The same applies to momentum and angular momentum. They are consequences of spatial symmetry. Change the symmetry, and the conserved quantity changes. The universe is not following rules. It is maintaining internal consistency. This consistency is mathematical. Even spacetime itself is described geometrically. General relativity does not treat gravity as a force. It treats it as curvature in a four-dimensional manifold. Objects move along paths determined by geometry. Mass tells spacetime how to curve. Spacetime tells mass how to move. Both statements are equations. Black holes are not dark objects floating in space. They are solutions to Einstein's field equations. Before they were observed, they existed as mathematical possibilities. The universe allowed those solutions to exist physically. Quantum mechanics deepens this strange alignment. The wave function is a mathematical object. It exists in an abstract space called Hilbert space. It is not located in ordinary three-dimensional space. Yet it determines probabilities of measurable outcomes with extraordinary accuracy. A purely mathematical entity predicts physical results. Why should this work? Why should abstract symbols written on paper describe the behavior of stars, atoms, and galaxies? This question is not rhetorical. It is one of the deepest mysteries in physics. Some argue that mathematics is merely a tool, that it works because we select structures that match observations. But this does not explain why the universe is describable by coherent mathematical frameworks at all. Reality does not behave randomly. It behaves structurally. The effectiveness of mathematics in physics is not trivial. It is precise. Equations predict experimental outcomes to astonishing degrees of accuracy. Quantum electrodynamics produces results verified to more than 10 decimal places. This level of agreement suggests more than coincidence. It suggests that the universe is not just describable by mathematics. It operates according to mathematical relationships. But what does that mean? It does not mean that numbers float in space. It does not mean that reality is a simulation running code. It means that structure, not substance, is fundamental. What we perceive as objects are stable configurations of relationships. An electron is not a tiny sphere. It is a set of properties defined mathematically: charge, spin, mass, interactions. Remove the relationships, and nothing remains. The same applies to space and time. In some approaches to quantum gravity, spacetime itself emerges from more fundamental mathematical networks. Geometry is not primary. It is derived. The deeper we look, the less stuff we find, the more structure we find. This leads to a subtle shift. Instead of asking what the universe is made of, physics increasingly asks what constraints must exist for consistency. Which mathematical structures are stable? Which symmetries are allowed? Reality becomes the physical expression of viable mathematical relationships. This does not eliminate mystery. It intensifies it. Why these equations and not others? Why these constants? Why these symmetries? Why is the universe structured in a way that permits complexity? Physics does not yet answer these questions. It narrows them. The search for unification, a theory that combines quantum mechanics and gravity, is not merely a search for a new equation. It is a search for a deeper mathematical coherence. When physicists propose string theory, loop quantum gravity, or other frameworks, they are exploring possible mathematical structures that could produce the universe we observe. Reality may be the intersection of consistency and possibility. This perspective changes the emotional relationship to science. The universe is not a collection of objects drifting in emptiness. It is a structured totality whose behavior reflects internal mathematical necessity. And within that structure, complexity arises. Stars form because gravity allows it. Atoms exist because quantum mechanics stabilizes them. Chemistry unfolds because energy levels permit bonding. Life emerges because information can organize within physical constraints. Each layer depends on mathematical stability. You are not separate from this structure. Your thoughts follow biochemical processes governed by physical law. Those laws are mathematical. Your capacity to understand mathematics is itself a product of mathematical regularity in neural systems. The universe has become aware of its own structure. This is not mystical. It is continuity. If reality is mathematical at its foundation, then understanding physics is not about discovering hidden objects. It is about uncovering patterns of necessity and possibility. The world is not made of things. It is made of relations that hold. And those relations are expressible mathematically. This does not reduce existence to cold abstraction. It reveals depth. The beauty of physics is not in spectacle, but in coherence. Equations written decades ago continue to describe phenomena at scales unimaginable at the time. Predictions emerge from symmetry arguments alone. Reality aligns with structure in ways that demand humility. The universe does not need to be tangible to be real. It needs to be consistent. And consistency, at its deepest level, is mathematical. We do not yet know why mathematics works so precisely. But every successful theory strengthens the same conclusion. Reality is not fundamentally material. It is structured, and structure does not require substance. It requires relation. The universe may not be made of matter, It may be made of mathematics, expressed physically. Still, within